Guys, welcome back. So we are looking at lesson 11. So yes, we did skip some lessons. We are looking at lesson 11 now. We are still dealing with the Pythagorean theorem. So we're going to go ahead and just jump right in. Alrighty. Okay, so looking at this first part here, we're finding distances in the coordinate plane. So now we're looking at being in the coordinate plane for things rather than just being values and shapes outside of the coordinate plane. So we are going to order the following pairs of coordinates from closest to farthest apart, and we're going to talk through the reasoning. So if we look at this first set of points, we have the point 2,4 and we have the point 210. Well, our x values didn't change, so there's no change there, but our y values did change. We went from 4 to 10. So how much of a change is that? 6, you're correct. Oops, forgot to put the annotate on. 1 second. Maybe. There we go. Bump that up a little bit. Okay, so like we said, it was 6. That's supposed to be a 6. Oh, gracious. Just does not want to write a 6, does it? Let's try again. 6. There we go. All right. For B, we're at -3, 6, and 5, 6. So this time the y values didn't change since they're both 6, but our x values did change. So we went from a -3 to a +5. So to go from -3 to 0 would be 3, and then from 0 to 5, well, that's another 5. So 3 plus 5 is 8. So we have a distance of 8. All right, the next one, we have the point -12, -12, and the point -12, -1. So our x values stayed the same at -12. Our y values, we went from -12 to -1, which is an increase of 11. All right, for D, once again, x values stayed the same. We've got 7, 0, and we got 7, -9. So how far did we go to go from 0 to -9? We went 9. Excellent. And remember, we can never have a negative distance. So even though we did go down to -9, it is a +9 for our distance. All right, and the last one, we have the point 1, -10, and we have the point -4, -10. So the y values stayed the same. The x values are what changed. So to go from -4 to 0 would be to add 4. And then to go from 0 to 1 would be to increase 1 more. So that would be 5 for our distance. So now we need to put these in order from closest to furthest apart. So what is our closest value? You're correct. It's E with 5. What's the next closest? A with 6. And next, B with 8. Next, D with 9. And so by process of elimination, C is last with the greatest being 11. Excellent. So for number 2, we're going to name another pair of coordinates that would be closer together than the first pair on our list. So we'll go ahead and keep the first point the same, so the point 2, 4. And what can our other point be so that it's closer than 6 apart? 2 and what? 2 and 6 will work. 8 will work. So anything as long as it's more than the 4. Well, we could go lower than the 4 and have a value that's still within that 6. That would work. But anything between 4 and 7 would work to be closer together. And then going within 5 different of 4 in the negative directions. That way it's less than that 6. Excellent. All right, there is a third question here, and it says, name another pair of coordinates that would be farther apart than the last pair on your list. So if we look at our last pair, we had one -10 and -4, -10, and it was 5 apart. So in this case, if we pick another one, so we'll keep the first point the same again. And what with our -10? What should we put with that so that it's more than 5? 10 will work, yep. So that is definitely more That'd be a difference of 9, which is much larger than 5. So there's lots of different possibilities here. As long as we have something larger than a distance of 5, we're good. All right, questions on these. This is all about those coordinates. Remember, when we're dealing with coordinates in the coordinate plane, it's always our x values first, then our y values. That'll be important here in a bit. All right, the next thing we're looking at is how far apart. We want to find the distances between the 3 points shown. So the easy two distances are obviously the vertical and the horizontal. So to go from negative 14, 9, we're going to pretend this line is nice and straight, down to negative 14, negative 3. So to go from 9 down to 0 is 9, and to go from 0 down to negative 3 is 3. 9 plus 3 is 9. Oops. 9 plus 3 is 12. Started with the answer before I wrote the question. So this length here is 12. Now we need to find the horizontal length. And once again, let's pretend this is a nice straight line, since it's clearly very far from that. So in this case, we're going from negative 14 for an x value to positive 16. So from negative 14 to 0 is 14. So this segment here is 14. And from 0 to 16 is 16. So we're going to add 14 plus 16 to get 30. You're correct. So this side, whole side here, is the 30. Now, we have a third side to take and find the distance between. Now, what we have so far, if we notice, is a right triangle. If we finish this off, drawing our line through here, we have a right triangle. And how can we find a missing side of a right triangle? Well, make this C. We've got our A value. We've got our B value. We could do the Pythagorean theorem. So A squared plus B squared equals C squared. So A squared is going to be 12 squared plus 30 squared equals C squared. 12 squared is 144 plus 30 squared is 900 equals C squared. We add these two together, so we end up with 1044 equals C squared. Remember, to get rid of a square, we always take that square root. So that cancels out there. So our answer is the square root of 1044 for our third side. So these are all figures looking at taking and finding distance within the coordinate plane. So still having triangles and taking and finding distances, we can take and do that. We can find the distance of the hypotenuse when we're in the coordinate plane. Remember, coordinate plane is your key word for this lesson. So it's all about using the Pythagorean theorem, using the two legs to help you take and find that third side with the coordinate plane here. Alrighty? Remember, if you guys have any questions, feel free to contact me. I'll try to get back to you as soon as possible. Have a wonderful day, and make sure you get your keyword and your assignments turned in. Happy mathing!